Uranus is a death sentence disguised as a destination. Imagine sitting inside a spacecraft, watching through a small window as Earth shrinks behind you. Not for days, not for months, for years. The blue dot fades until it's indistinguishable from the stars around it. You're heading to one of the most distant planets in our solar system, an ice giant nearly 3 billion kilometers away. A world with no ground to stand on, no air to breathe, and winds that would rip a building apart in seconds. By the time you arrive, you won't be the same person who left. Your bones will be brittle, your heart will have shrunk, your brain will carry permanent damage. And even if you wanted to turn around and come home, the journey back would finish what the journey there started. This is the reality of a mission to Uranus, first discovered by William Herschel in 1781. Not because we lack the technology to get there, but because getting there means your body will never survive the return. Let's start with the most basic and most brutal fact. Uranus is far. Not Mars far, not Jupiter far. Uranus orbits the Sun at an average distance of about 2.9 billion kilometers. To put that into perspective, Mars at its closest is roughly 55 million kilometers from Earth. Uranus at its closest approach is still about 2.6 billion kilometers away. That's nearly 50 times farther than Mars. When Voyager 2 launched in 1977, it took advantage of a rare planetary alignment that happens roughly once every 175 years, using gravity assists from Jupiter and Saturn to slingshot itself outward. Even with those boosts, it took 8 years and 5 months to reach Uranus. And Voyager 2 was a small, lightweight probe with no life support, no food, no water, and no humans on board. A crewed spacecraft would be far heavier. It would need to carry everything required to keep people alive for years, including oxygen recycling systems, water filtration, food supplies, medical equipment, and enough fuel for course corrections. All of that extra mass means slower acceleration. Realistic estimates for a crewed mission to Uranus put the travel time somewhere between 12 and 15 years, one way. Think about that for a moment. 15 years inside a metal container. No open sky, no fresh air, no weather, no seasons. Just the hum of machinery and the silence of deep space outside. And that's assuming everything goes according to plan. The first enemy is invisible. In deep space, beyond Earth's protective magnetic field, cosmic radiation floods through the spacecraft with almost nothing to stop it. On Earth, our atmosphere and magnetic field shield us from 99.9% of this radiation. On the International Space Station, astronauts are still partially protected by Earth's magnetosphere, yet they receive roughly 150 millisieverts per year. That's already 50 times more than what you'd absorb on the ground. In deep space, there is no shield. Galactic cosmic rays and solar particle events bombard the spacecraft constantly. Over a 12 to 15-year journey to Uranus, the cumulative radiation dose would be staggering. NASA's current career limit for astronauts is 1 sievert, which corresponds to roughly a 3% increase in fatal cancer risk. A round trip to Mars alone, which takes only 2 to 3 years total, would already push close to that limit. A mission to Uranus would blow past it many times over. The damage isn't just about cancer either. Radiation breaks DNA strands. It accelerates cardiovascular aging by decades. It damages the brain, causing measurable cognitive decline, memory problems, slowed reaction times, and difficulty making decisions. It weakens the immune system by damaging bone marrow. And here's the part that matters most for the question of coming back. This damage is cumulative and irreversible. Every particle that tears through your cells adds to the total. Your body's repair mechanisms can't keep pace. Even if you somehow turn the ship around halfway through, the damage already done would follow you for the rest of your life. But radiation is only the first domino. While it quietly shreds your DNA, something equally devastating is happening to your skeleton. On Earth, gravity constantly pulls on your bones, and that stress is what keeps them strong. Your body is efficient. If it doesn't need to maintain bone density, it won't. In weightlessness, the signal to build bone disappears. Astronauts on the space station lose about 1 to 2% of their bone mass per month. After 6 months, they come home and need weeks to walk normally again. Some never fully recover their original bone density. Now extend that to 12 or 15 years. After just 5 years in weightlessness, your skeleton would resemble that of an 80-year-old with severe osteoporosis. After a decade, the bones that once held you upright on Earth would be so porous and fragile that stepping out onto a planet with normal gravity could shatter them. Astronauts on the space station exercise for 2 hours every single day, using specialized resistance equipment, and they still lose bone. On a spacecraft heading to Uranus, no amount of exercise would be enough to counteract over a decade of zero gravity. Your muscles suffer the same fate. Without gravity to work against, they atrophy. The legs, the back, the core, everything the body uses to stand and move on Earth begins to waste away. Your heart, which is also a muscle, starts to shrink because it no longer needs to pump blood upward against gravitational pull. Studies on astronauts show the heart can lose up to 20% of its mass during extended space missions. Blood volume drops. The cardiovascular system restructures itself for a world without weight. When astronauts return to Earth after just 6 months, many of them faint when they try to stand up. Their hearts can't push blood to the brain fast enough. After 12 to 15 years, the heart wouldn't just struggle. It would likely be incapable of functioning under Earth's gravity at all. It would have become the heart of a different world, reshaped for weightlessness, and utterly unfit for the planet that built it. And then there's the mind. Isolation research conducted on Earth shows that even highly trained, carefully selected individuals begin to break down psychologically after extended periods of confinement. And those studies have emergency exit options. The subjects know they can leave if they truly need to. On a spacecraft bound for Uranus, there is no exit. No door to open, no walk to take, no phone call that arrives in real time. At Uranus's distance, a radio signal takes over 2.5 hours to reach Earth. A conversation with mission control would have a round-trip delay of more than 5 hours. You send a message, you wait, and you wait. You are, for all practical purposes, alone. Depression, anxiety, cognitive impairment, sleep disorders, interpersonal conflict within a small crew locked together for over a decade, these aren't hypothetical concerns. They are near certainties. So let's say, despite all of this, you survive the journey. You arrive at Uranus after more than a decade. What's waiting for you is not a destination. It's a death sentence wearing a pale blue mask. Uranus has no surface. It's an ice giant, which means beneath its atmosphere there is no ground, no rock, no place to set down a lander. The planet is mostly swirling fluids, a thick soup of water, methane, and ammonia compressed to pressures that would crush any structure we could build. A spacecraft descending into the atmosphere wouldn't land. It would simply be squeezed and heated until it ceased to exist. NASA itself has stated plainly that the extreme pressures and temperatures would destroy a metal spacecraft. But even if you could somehow hover in the upper atmosphere, the conditions there are nightmarish. Uranus holds the record for the coldest planetary atmosphere in our solar system. Temperatures at the cloud tops plunge to negative 224 degrees Celsius. That's colder than Neptune, which orbits 1 billion kilometers farther from the Sun. At those temperatures, exposed human skin would freeze solid in seconds. The atmosphere consists of 83% hydrogen, 15% helium, and 2% methane, with traces of ammonia and hydrogen sulfide. That last one is the chemical responsible for the smell of rotten eggs. If you could somehow take a breath on Uranus before the cold killed you, the stench would be the last thing you'd notice before the lack of oxygen finished the job. And then there's the wind. Uranus may look calm and featureless in photographs, but that serenity is a lie. Wind speeds on the planet can reach up to 900 kilometers per hour at mid-latitudes. To put that in context, the most powerful hurricanes on Earth top out around 300 kilometers per hour, and those flatten cities. On Uranus, the winds would tear apart any vehicle, any habitat, any structure that dared to exist in their path. Then there's something about Uranus that makes it unlike any other planet in the solar system. It's tilted, not slightly like Earth's 23-degree lean. Uranus has an extreme axial tilt of nearly 98 degrees. It essentially rolls around the Sun on its side, like a ball rolling across a table. Scientists believe this happened billions of years ago when an object roughly the size of Earth collided with the young planet and knocked it over. This obliquity creates the most extreme seasons in the solar system. For nearly a quarter of each Uranian year, which lasts 84 Earth years, one pole faces the Sun directly. That means if you were standing on the North Pole of Uranus, you would experience 42 years of continuous, unblinking sunlight. No sunset, no night, no relief. And then, slowly, the planet's orbit brings the opposite pole into view. The Sun sets for the last time and doesn't rise again for another 42 years. Imagine being born on the dark side. You would live your entire life, grow old, and die without ever seeing the Sun. The magnetic field only makes things stranger. On most planets, the magnetic field roughly lines up with the planet's spin axis, like a bar magnet running through the poles. On Uranus, the magnetic axis is tilted nearly 60 degrees from the rotational axis. And it doesn't even originate from the planet's center. It's offset by about a third of the planet's radius toward the South Pole. The result is a magnetic field that's lopsided and chaotic. The field strength varies wildly across the surface, from as low as 0.1 Gauss in the southern hemisphere to 1.1 Gauss in the north. Studies of Voyager 2 data suggest that this distorted magnetosphere connects with the solar wind once every Uranian day, about every 17 hours, effectively opening the planet up to bombardment from the Sun's charged particles. Recent analysis of Voyager 2 data suggests the spacecraft may have caught Uranus during an anomalous solar wind event, conditions that occur only about 4% of the time. If you were depending on Uranus's magnetic field to shield you from radiation the way Earth's does, you'd be out of luck. The shield has holes in it, and they open and close on a schedule dictated by a planet rolling sideways through space. Even Uranus's 27 known moons, including its largest satellites, Titania and Oberon, offer no refuge. These distant, icy worlds are as inhospitable as their parent planet, locked in eternal cold and darkness for decades at a time. This is the world you'd reach after 12 to 15 years of travel. A world with no ground, no breathable air, temperatures that freeze metal, winds that shred steel, and a magnetic field that offers protection only some of the time. There is nothing here that a human being can use. There is nothing to mine, nothing to build on, nothing to sustain life. Uranus is a place to study from a safe distance, not a place to visit. And the cruelest part is this. Even if you could survive the journey and somehow orbit the planet safely, turning around and going home wouldn't save you. The return trip would take another 12 to 15 years. That's a total of 25 to 30 years in space. By the time you got back to Earth, your bones would be hollow. Your heart would be too small and too weak to pump blood against gravity. Your muscles would be gone. Your brain would carry the scars of decades of radiation exposure. Your eyes would likely be damaged. Your immune system would be wrecked. Stepping out of the spacecraft onto Earth's surface might literally kill you. Your body wouldn't be built for this planet anymore. It would have become something else. Something shaped by weightlessness and silence and the slow, invisible erosion of everything that once made you an Earthling. We've sent exactly one spacecraft to Uranus. Voyager 2 flew past it in January of 1986 and collected most of its data in just 6 hours before continuing on into the outer solar system. That brief flyby is still the only close look we've ever had. In 2022, the Planetary Science Decadal Survey declared the proposed Uranus Orbiter and Probe mission to be a top scientific priority for the coming decade. If that mission happens, it will be a robotic probe, not a crewed ship. Because we've learned enough about what space does to the human body to know where the line is, Mars is on the edge of what we might attempt. Jupiter pushes well past it. Uranus isn't just beyond the line, it's in a different category entirely. There's a certain clarity that comes from understanding the limits of what our bodies can endure. We are products of this planet. Every bone, every heartbeat, every breath we take is tuned to the gravity, the atmosphere, and the radiation environment of Earth. Take us away from that for long enough, and the tuning breaks. The instrument can't play the same music anymore. Uranus sits out there in the cold dark, spinning on its side, wrapped in methane and mystery. And it will keep its secrets a little longer. Not because we can't reach it, but because reaching it with human hands would cost us the very thing that makes those hands worth sending. Thanks for watching, and I'll see you in the next one.